In this tutorial, we will be discussing the background information for covalent bonds. When nonmetals bond with other nonmetals, a molecular compound results. Molecular compounds contain covalent bonds, not ionic, in which electrons are shared between the atoms rather than transferred. So molecular compounds from nonmetals and nonmetals bonded together where the electrons are shared. In Lewis theory, we represent covalent bonding by allowing neighboring atoms to share some of their valence electrons in order to attain octets. Remember, octet means that they're looking for 8 electrons. Alright, so let's look at water, for instance. Hydrogen and oxygen have the Lewis structures of the elements as, here's hydrogen. It's in the first row, so it has 1 electron. Oxygen is in the 6th row right here, so it has 6 electrons. Remember, go all the way around once, and then you go back and you pair up the electrons. And that's why we have 2 that are paired and 2 that are not. In water, hydrogen and oxygen share, not transfer, their electrons, so that each hydrogen atom gets a duet and oxygen atom gets an octet. So here, if I look at oxygen, 1, 2, 3, 4, 5, 6, 7, 8. If I look at hydrogen, it still has a duet there of 2. The shared electrons, those that appear in the space between the 2 atoms, so right in here, count towards the octets and duets of both atoms. So this circle contains all the electrons that are involved in oxygen, while this circle contains all the electrons that are involved in hydrogen. Electrons that are shared between 2 atoms are called bonding pair electrons. Electrons that are only for 1 atom is called the lone pair or non-bonding electrons. So here are the bonding electrons, here are the lone pairs. In this particular molecule, we have 2 sets of lone pairs on the oxygen, and we have 2 sets of bonding pairs between the oxygen and hydrogen. Here's one bonding pair, here's the other bonding pair. Bonding pair electrons are often represented by dashes to emphasize that they are a chemical bond. So those 2 dots between the oxygen and hydrogen then become a line between the oxygen and hydrogen. Remember that each dash represents a pair of shared electrons. So each dash, each line, is equal to 2 electrons. So let's take a look at diatomic molecules and why this can explain diatomic molecules as well. So if we look at the Lewis structure for chlorine, chlorine is right here. 1, 2, 3, 4, 5, 6, 7. It's in the 7th row, so it should have 7 electrons. 2, 4, 6, and then the lone electron of 7. If 2 chlorine atoms pair together, they can both attain the octet. So if we have 2 chlorines right next to each other, both equal with 7 electrons, you have 2 electrons between them to form 1 bond. So those are the bonding electrons. When we examine the elemental chlorine, we find that it exists as a diatomic molecule, just as Lewis theory predicts. The same is true for the other halogens. It's also true for hydrogen. Hydrogen has the Lewis structure of just 1 dot because it's in the 1st row. When 2 hydrogen atoms share the valence electrons, they each get a duet, a stable electron configuration for hydrogen. Both of those electrons are shared, so therefore both hydrogen have those 2 electrons. And then that can be represented as a line. Lewis theory is correct. In nature, elemental hydrogen exists as an H2 molecule. In Lewis theory, atoms can share more than 1 electron pair to obtain an octet. If we pair two oxygen atoms together and then try to write the Lewis structure, we do not have enough electrons to give oxygen atom an octet. So instead, we end up sharing two unshared electrons. We can convert a lone pair into an additional bonding pair by moving it into the bonding region. So if we do this, here's the bonding. We can move this one into it to give a total of 4 electrons. That then becomes 2 lines because each line represents 2 electrons. Each oxygen atom now has an octet because the additional bonding pair counts towards the octet of both oxygen atoms. So we have 2, 4, 6, 8. 2, 4, 6, 8. The Lewis theory atoms can share more than one electron pair to obtain an octet, and the same for nitrogen. Consider the Lewis structure for N2, where N is right here. It's in the 5th row. So therefore each of them have 5 electrons around it. 3 singles and 1 double. The Lewis structure for N2 has a total of 10 electrons. 2, 4, 6, 2, 4, 6. They're still short electrons. So therefore, we can actually move more of those lone pairs over to form what eventually becomes a triple bond. If we convert 2 lone pairs into bonding pairs, each nitrogen atom can get an octet. When 2 electron pairs are shared between 2 atoms, the resulting bond is a double bond. In general, double bonds are shorter and stronger than single bonds. For example, the distance between the oxygen nuclei and the oxygen-oxygen double bond is 121 picometers, where a single bond is 148. So a double bond is 2 electron pairs, and they are shorter and stronger. While Lewis theory does correctly predict a double bond for O2, it is insufficient to explain the paramagnetic properties of oxygen. This problem led to the development of other bonding theories. We will not discuss these in this class. Triple bonds are even shorter and stronger than double bonds. The distance between nitrogen nuclei and a nitrogen triple bond is 110 picometers, while the double bond is 124. When we examine nitrogen in nature, we find that it exists as a diatomic molecule and is a very strong, short bond between the 2 nitrogen atoms. The bond is so strong that it is difficult to break, making N2 a relatively unreactive molecule. And that's your background information for Lewis structures.